We have a good number of updates from our team. And so if you do have any questions as we're going through those items, feel free to put those items in chat, but we'll have some open Q&A at the end after we go through some updates on our end. Just wanted to remind everyone of our format. We have our weekly office hours, if this is your first time joining, that's weekly from 8 to 9 a.m. Pacific time for those who are based in US and EMEA. And then we also have our monthly APAC office hours. We'll have our meeting this Wednesday and actually later today. And those are on the second Wednesday monthly from 4 to 5 p.m. Pacific time. So if you do have folks that are based in APAC who are wanting to join, please make sure to forward the invite or reach out to me and I can help with that. In the interim of our office hours, we do reply quite frequently and we go through daily triage for our GitHub discussions. And so it's another great place to look. And then we've recently migrated our Discord to a broader Azure AI community as well. And so it's another really great place to go to get support and learn from others as well. With that, I'm going to dive into a couple of updates from my end. There are a number of releases that have been out since we met last. And so there is a very large release for Python 1.27 that has a lot of different updates. The one that I've highlighted here for 1.27.2, there's some updates to our README. We've gone through and improved the plan and execution sample. And then there are just some bug fixes as well. But if you haven't had a chance to look at the last couple of Python releases and updates, we recommend you do, as there's been a lot of changes and a lot of goodness there. And then moving to .NET, I want to highlight our 1.45.0 update that was recently pushed out. There's some updates in terms of adding clarity and alignment for some of our blog posts and some of our items there. There's an MCP prompt sample. We're going to dive into some MCP updates here shortly. And then there are some updates in terms of the experimental chat history agent as well. And so if you haven't had a chance to take a look at this one, we recommend that you do. I'll put some links in chat as well. And the first one is to our releases. In terms of blogs, we've had a lot of updates. We will cover some updates around agents being GA. There's a guest blog that we'll cover today as well, but the one that we'll cover in upcoming office hours is around some of our vector store updates and connectors. And so if you haven't had a chance to read through these blogs, it's a great time to go through them. But what I'll go ahead and do for the interest of time is dive into a couple of blog posts and samples we want to dive into. I'm going to turn it over to Estefania, and we're going to go through a human in the loop sample. Estefania, over to you.
Hello everyone. This sample, it's got published yesterday. It's also in the Learn website. So first of all, I'm gonna explain you what this is. So the example here explains how let's say user wants to generate some documents. This will encounter probably three main steps. The first one is to gather the product information, then potentially generate the document. Then another step we have is we call it a proofread documentation step. In case, I don't know, there are typos or something else. So hypothetically, if there were typos or the format is not respected, the generate document step will go again until the document, let's say it's approved. Once it's approved, this document is going to be sent to the user for the user to finally give the final approval. And then, as you can see, this one is an external interaction with a semantic kernel process. And then once the user approves or rejects, this is going to come back to the process and then it's going to resume. Assuming the document gets approved, then the document is going to get published and that's the end. Assuming the user rejects it, we're going to back to the left. The user rejected document event. It's gonna go back to the generate document step, and taking into account the suggestions, it's gonna go back again, and then the flow will continue. So I'm gonna show you a live demo, but first I just want to explain the main things and how this happened and this sample in particular. So regarding how this happens, is that you might actually create your own process as you would before. The new addition is that right now, at least, well, there are two steps. Sorry, the step is a very overused word here for us. There are two main aspects here. One is to broadcasting externally, and one is receiving events from external sources, right? So at least for broadcasting events externally, we can focus on the last like the last steps in Doc's proofread step. In the comments I added there, like there's this new thing that you actually craft the process as before. It's just that now you have you can make use of this emit external event, and so and it's going to forward the event to this proxy step with this specific topic name. Likewise, as I mentioned, and this in the sample, there are there are two places where this happens. One is like when the document is ready for like the user to review, and the other one is when the document is ready. So in this case, you can see how at the end we're only forwarding when the request user review and when the published document it's when the document is ready. For taking into account events from external events, that's where we actually have, let's call it, different input events. So as you can see, we have start document generation, which means it's just for like getting the whole process started. So that one is not new. And then the other ones is just because the user either rejected the document or approved it. And depending on how it's structured, they're going to be piped in different steps of the process. So as I mentioned before, if the user actually rejected the document, this is going to get piped to the generate document step to like take into account the suggestions and kick off the process again where it was. But if the user approved it, then it's going to go straight to the published document, and whatever document got there last, that one is the one that is going to get published. So like it's like here is in the terms of the process itself. Now, what is this proxy step? So this proxy step is pretty much like an abstraction that allows you to pretty much integrate any cloud event service you want. And so like this proxy step under the hood is uses to the left. You're going to see this class I called my cloud event client. You can create whatever you want here. So like what it means, if you want to use gRPC, go ahead. Just like replace the according logic to initialize or initialize and set events. You want to use SignalR, you can use that too. You can want to use that per pops up, that also would work too. So like on that regard, as you can see in the process, it's agnostic. It doesn't even know what it's going to be using. It's just using the proxy step. But in reality, under the hood, it's going to be using this abstraction to the left to actually send events to whatever client you use. This, of course, is going to assume that whatever client you're creating here is going to have some server running somewhere that is going to be listening to. So like they're gonna stop here and before jumping into the demo. So like if you have any questions, feel free to ask. If not, I just go ahead to share my screen and show you like a quick demo of this little process.
Hi, yeah, regarding this, I just had one quick question. Like, do you have any equivalent of this in like Python as well, or is it all predominantly C# for now?
Right now it's only C#, but we're planning on supporting on Python.
All right, great. Thanks.
And
Thank you for the question.
Sorry.
Oh,
Yep,
go for it. Sounds like there's another
yeah.
question. Would love to hear from you if you want to come off of mute.
Yeah. Just in this workflow, are you kind of also storing the state as to for each of the, if there are multiple process flows, are you storing the state of each of these to be able to track?
Yes. Yes, actually this sample is available in the GitHub repo, so like you can take a look. But there are only a couple steps that are actually stateful. One of them is the generate document step, because it kind of holds like whatever document was generated previously. And I believe the publish document step is the other one that is stateful. The other ones are kind of done. So like yeah, but you can take a look at this sample in the GitHub repo. I'll be sending the link here in the chat. But yeah, you can take a look at it.
Okay, thanks.
And a follow-up question there, all these events, these are all configurable, right? These are all, they're not set in stone, right? Looking at the code, that's what I understand, but just want to kind of confirm. I can define the events that I want, right?
Yep, that's correct.
And then do you have an example of something like this working on with a web, right?
With web, yeah, well, actually, like I was working, the sample that I have published is with gRPC. I had some sample working with gRPC web. There's some issues because it seems like there's at least with gRPC, there's miscompatibilities using gRPC with HTTP2 and gRPC web. So that's one weird one. But I had created a prototype in the past using Signal R, for example, and having like a React app.
Yeah, that would be awesome if it can be shared.
Someone is not muted.
Yeah, I'm just muting. And then looks like we have a hand up, Jose, and they'll take this last question before we go into Estefania's demo. Jose, would love to hear from you.
Yes. Hi, Stefania. Quick question. This implementation, I guess, a lot of parts of the tasks here, or the steps, properly saying that, are done by agents, right? Are all the agents participating on the same thread? So maybe it would be kind of nice to see all the conversation which is going, and the agent later has access to it, and the part that's one part of the question, and the other is the parts where the user has to interact, right? It would be great to have an agent that kind of acts as the human in the loop agent that talks and requests the confirmation of the user. Probably that's not happening. I don't know. I have not seen the code. I think, as you mentioned, it's pretty new. But if it happens, that would be great to see. And if not, I think it would be interesting to have that, like a kind of having one agent, which is the proxy to the user, just saying that loud. I think that would be nice. And also the ability to be able to see all the conversation going through. I know they can happen in a distributed way, right? All the different steps, and a step can be also a process, but just saying that it would be pretty nice to have this feature. Just thinking thinking loud. What do you think of these questions?
Well, this sample is like way simpler than you just mentioned. It's like this, like if anything, the only one that holds like the chat history is the generate documentation step. The rest are pretty done. So like in this regard, like we don't have like this whole thing like a multi-agent stuff situation going on here. Also, right now the process framework does not have like a shared, let's say, like state across steps. Assuming like you want to like share the whole history across different steps. Like we don't have that right now. So like on that regard, you might be referring to like the agent framework, not this one. So like that's one clarification I wanna like to do it there. Yeah, so at least for now, sorry about that. We don't really have that yet. Yeah, so like going with that, I'm gonna go proceed to share my screen and go with a demo.
Perfect, thank you.
Okay, just one moment. Is the right screen? Yes. Okay, cool. Alrighty, so okay, yeah, so this is gonna be a multi-screen demo, so bear with me. So the first thing I wanted to show you, like this demo is using Dapper under the hood. So the first thing is that all the potential actors that we might be using, they're all here. Like they're like just like the internal components under the hood. So then I already have my process running. I already set some breakpoints, so like we're gonna see some stuff happening. Then here, just for simplicity, I use like this common like gRPC web UI thing. So like here, I already have like two. Let me just clear this one up, so you know I'm not cheating. Yeah, there you go. Cool. So request feature. No, it's this one. Okay, so gonna have two requests ready. One is just like first to like start a process. So like let's use some process ID 2000. And here, this is one for like the one of like receiving the event. So like the reason is like I will be using the same process ID. So like I subscribe when it happens. And here, this thing is a little bit annoying. So like I have to set a timeout to get the signal. So I'm gonna use the same ID for both. So this one is already in. Cool. Described. And now I'm gonna kickstart the other one. Invoke. So here the process is about to start. So like then let me just go back here, there's a bunch of logs. Let's go to the upper logs. So here, there's a bunch of logs coming from the steps. There's this generation document step going on. By default, it's going to go on a loop, as I explained before. This is about to launch the external event. As you can see, this is the external event happening. There's a bunch of topics, request is review, the whole message. I'm going to show you the whole thing once it's get there. This is going to kick it out. And now it was emitted. So like here, what is important is that all the steps that I mentioned before, that's why I wanted to like explain so that you don't get lost into all these logs. It already happens. Like there's already was like some tokens that happened, like some model ran, it generated the document, it proofread it, and now it got emitted. So now if we go back to this tab over here, so this one already returned, that's with the process ID as it was. This one, it already returned something. So like here, it's kind of like hard coded. So like the only thing that I provided was like a title. But as you can see, it generated document, my fabulous product with a bunch of text and whatever you want. And so now it is ready for approval or rejection. So here for simplicity, I'm just gonna go here and just gonna say, yes, I approved. If I wasn't, I could potentially put in here and with a reason, and then it's gonna like go and do it again. So now what is important in this breakpoint right here is that, as you can see, it has two inputs. It has actually like oh, never mind, this is not the one. Here, this is the step that is important because it's the published documentation. And as you saw, the document was already published before, right? What was missing was the user approval. So like, as you can see, the document was persisted, and once the user approved, the missing parameter was piped in, and now it's right here. So it's ready to be published here. So like here, this is like pretty much like the last step I show you. So like now, that's it. So like I could have like subscribed to that published document, but like I have already too many tabs open, so like I didn't. But hopefully this show you how, for example, if we go back to the PowerPoint, here this is like the important thing, because as you saw, the user got to see the document, approved externally, and it went back into the process, and the whole thing resumed and worked properly. So that's the demo I had for you guys.
Perfect. Thanks so much, Estefania. I really appreciate it. I'm going to go to our next topic. Our next item that we are going to cover is MCP and going through for .NET and Python. Sergey, do you want to cover .NET first? Would love to hear from you.
Sure. So give me a second. I'll share my screen. Hopefully you can see it.
Yep, I can see. Can others see as well?
Yes.
Okay. Thank you for confirming. So last of office hours meetings, we've showed how you can, using Semantic Kernel, in order to create MCP server. And this time we're going to show you how to expose SK handlebars prompt template as an MCP prompt, and how to build MCP resource using Semantic Kernel. So let's start from the exposing handlebars prompt template as MCP prompt. In order to do that, you need to create the SK handlebars prompt template itself, and it's a very easy one. So most likely you already saw it before. So you need to specify name, description, format, then provided input variables and whether they're required or not. And then you also need to provide template itself. And this template here is not just a string, it's a string with placeholders, and those placeholders will be filled with the values when the template will be rendered using the city and time arguments provided by end client app who wants to use that's prompt template. And second step you need to take in order to expose that handlebar semantic kernel prompt template as MCP template, you need to basically run this line. And this line reads that prompt template you just saw from the embedded resource as a string, then create a prompt definition from it, and register it with MCP server, and MCP server automatically exposing it. And when registering that MCP prompt definition, we are registering two things. We are registering the handler that will be called by a client when client wants to look at all the prompts available on the server. And we're also registering a second handler that client will have to call in order to get a content of a certain prompt. So let me show you how this prompt template looks from the client side. If I quickly go to the Claude app, and you will see that there is like a few icons. And by the way, this Claude app, desktop app, is connected to that MCP server that I'm running locally. And if I click on this icon, in the dropdown, I can see two things here. First one is the prompt template itself, and the second one is get image. So I'm going to talk about it in a few minutes, but like for now, let's look at this get current weather for city template. If I click on it, it will ask me to provide the values for two arguments. One is city. So let's say that I would like to get a weather for Boston, and I'll basically type Boston here. And then I'll also insert a time and click submit. And as you can see, the prompt wasn't sent to LLM yet, so it was added as like a card, and I believe it just like added as a context. And let me do again same thing, but this time I'm going to provide Sydney, and again put the same time. So now both prompts are added to the context, and now I can start the prompting the model. And I'd like to ask the model just to compare the weather into two locations and provide the best activity for each location depending on the weather. And if I send it now, ideally I should see that LLM will use the context from the prompt. Oh yeah, so what happens here is it's basically human in the loop together with, while exposing the prompt itself, MCP server exposing a bunch of the tools, and LLM for some reason decided to call one of them. In this case, you can see the name of the tool.
Sergi, can you make it a bit bigger, the font?
Let me try to scroll.
Thank you.
The other thing you can do, Jose, as well, is in the Teams window, if you hold down the control key and then scroll in with your mouse, it'll make it bigger as well.
That could be probably the only thing you can do, because the thing is the Cloud desktop app is not, at least it's not scrollable, or not. It's not possible to zoom for me using the Control and Plus.
I did what you suggested, and it works like a charm. Thank you so much.
Oh yeah, thank you for that. And yeah, so as you can see, just like LLM decided to call a tool, and like they're having this human in the loop experience. So I don't want LLM to call a tool because all the context is available via those prompts. I click in deny. And as you can see, even so, LLM was able to reason about the prompt. So it basically successfully extracted the temperature provided by the prompt for both, from the prompts for both Boston and Sydney location, and did a weather comparison and doing the activity recommendation. So MCP prompts, which were originated from the Semantic Kernel handlebars prompts, were added to the Cloud desktop context and were used by LLM in order just to as a context for the prompt itself. Okay, quickly going back to the Visual Studio. Second thing I would like to show you is to how expose MCP resource from the MCP server. And again, so we've tried to simplify it and do it as simple as possible. And for now, it's like kind of like a one-liner. So, and in order to do that, first of all, you need to create a blob resource definition, provide a kernel, provide the resource URL. In our case, I'm going to have like a cat image. Then you need to provide like a human readable name so that it's cat image. Then you need to provide the content of that resource itself. And then you need also provide a content or basically MIME type of that content. And the image that resource is created for is just this, I don't know, Alice in Wonderland cat. And again, if I go back to Claude, and for example, if I again click on the icon, by the way, let me try to zoom here a little bit. No, it's not, it doesn't list, so it's probably not like a browser based. Anyway, so I'll click on the icon click on the drop down, and I can see that the cat image, which I've just shown you, just is shown in the list of the resources. And if I click on it, again, similar to the prompt, it will be added as a context, not to send LLM yet. And then I can ask basically the LLM to describe that image. And if I run the prompt, again, so that image was added as a context to the chat history or the list of the chat messages and sent to LLM together with my initial prompt. So I'll pause here to answer your questions you may have, and before I'll pass it over to Edward, who is going to show MCP for Python. So I'm stopping sharing.
Great,
I had
thanks so
a
much,
quick
Sergey.
question. Not sure if this was addressed, right? How well does MCP work in a web context, right? Rather than more from a desktop scenario.
So okay, the sample I've showed you where basically I have like this Claude desktop app, right?
Mm-hmm.
And the server the app connected to was kind of like standard input-output server, which was kind of basically sitting in as an exe file in the folder on my hard drive, and I pointed the Claude desktop app to that exe file. So that's one way of connecting to MCP server. There is another protocol which is called SSE that you can leverage in order, for example, in case your MCP server is sitting somewhere on a remote host, somewhere on Azure or any other hosting platform. So that's doable as well.
Perfect, thanks for the question.
Just adding that, I put recently a sample using that. So if you're curious, I can share the repo. It's open source in there.
Yeah, that would be
definitely
great.
Yeah.
And another sample can be found in the official .NET MCP GitHub repo. They have very good sample showing how you can turn your ASP.NET Core app into SSE server with basically two liners. One is saying add MCP server, and then second liner is map MCP or something like that, basically. And when you do that second liner, it's creating two endpoints from that MCP server, which MCP client can understand and use in order just to talk to the server.
Great, thanks so much, Sergey. Really appreciate it. If folks have other questions, if you could put them in chat, I would really appreciate it. And then I'm going to head over to Edward now for Python. Edward, over to you.
Yeah. So just like for the .NET side, we've been putting a bunch of effort on the Python side for MCP as well. So both sides of the coin. So basically taking an MCP server, exposing them as functions in your Semantic Kernel instance or your agent, as well as the same setup that Sergey just showed, where we can take existing kernel functions and expose them as an MCP server. So on the Python side, I did it a little bit differently, but the end result is pretty similar. So let me share my screen. Should be coming up. Let me zoom in a bit. So here we have just a really basic kernel. I'm creating one function that is just a code-based function, and then one function that uses a prompt and a model to basically repeat what was said. So it's really demo stuff. But then after that, all I need to do is call kernel.asMCP server. And I have a bunch of settings that I can do here. So I can set the name of the server, the version, some other pieces that MCP expects. And what I get back is a MCP low-level server for the people who are working with Python. This is fully available. So if I want to add even more stuff, so if I want to add like list resources to it, I can just extend this this function before I run it. Even if we on the Semantic Kernel side do certain things with it, it's still open for you to add even more to it. And then this function takes some parameters, so you can either run it as an SSE server, so you can connect to it through HTTP, or with STD IO. And that's it. So it's quite simple, as you can see. It's basically you create your kernel as normal, expose it as an MCP server, and you're off and running. I also loaded this into Claude. So here I have these two tools, so the prompt and the echo function. And I can ask Claude to use it. The Claude desktop app, if you're familiar, always ask for permission before running a function. So it does that as well here. And it comes back with the result. So, local function exposed through MCP towards the Claude desktop app in this case, but works equally well with other interfaces. On the other side of the coin, we have support for MCP STDO. Mute. As well as SSE plugins and even WebSocket plugins, which the Python SDK for some reason already supports, while that not being fully documented. I basically pass in the same arguments that I'm used to passing towards the Claude desktop, or even the Visual Studio Code GitHub Copilot agents can now use MCP servers. So command and args, if I'm doing SSE, it's just the URL. I then get this plugin object that I can just pass as any other semantic kernel plugin. In this case, I'm passing it to a chat completion agent. In my environment, the token used to connect to GitHub is already present. So all I have to do now is start actually interacting. So let me run this one, and then you can see a whole bunch of issues being pulled up from GitHub through MCP towards my agent that can interact with it. So let's give it a sec, because there's actually a lot of stuff happening in GitHub. So it's a big query. So there it's going. And there we go. We have the couple of the latest issues that are Python tagged in our GitHub, in our semantic kernel GitHub. So just like that, I can now start interacting with GitHub through MCP without having to do anything new other than adding the plugin like this. It has an async context manager. You can also manually call connect and close if you have a different setup. But that's about it. So anybody wants to ask any questions on MCP for both Python and .NET, feel free to come off mute or post them in the chat.
Yeah, we'd love to hear from you.
I like to make a question. First, I think the progress you're doing is amazing. So in short term, you're mostly supporting almost everything, including server. So I found out after playing all my past weekend with it that Sergey had already a server using Semantic Kernel, and today it can already support prompts and resources, which I expect follow-up blog post, Sergey, on that. That would be amazing, or a demo. I will definitely later on search for some sample there, because it's pretty exciting what's going on. It's super powerful. My question is to Sergey and to you as well. Basically, what are the plans for the prompt part? Not the resources. The resources is pretty clear, but what excites me the most is the power of prompts. Concretely, if you read the documentation, they mention workflows, and you know, Ben, where I'm going, right? Workflows. So it kind of, you can streamline and define some workflows that will be followed by, and you can define them already in MCP. So telling it, okay, this is how I want to define a task. And these are the prompts that you have to execute as prompts, or maybe even as agents, right? Because I think it's what's coming. So I wonder if this is kind of clear. It's still shaded in the documentation. I was wondering if you have any plans on this implementation. Just being curious, as well as how this will be affecting the incoming process framework, of course.
Yeah, that's a good question. So we are learning MCP as well, and like going through the spec and just trying to see what we can just what we can add from the semantic kernel side in order to allow allow folks just to leverage the semantic kernel for building their apps using the MCP. Yeah, we definitely saw the using workflows and referencing resources from the prompts. That's area we plan to explore as well. For now, we're just like doing with the simple scenarios, and while we're doing, we're kind of like learning the protocol itself. And after we've done with the simple ones like resource templates, the sampling as well, maybe we'll dive a little bit deeper and like investigate the how to export the workflows via the prompts and how to reference resources from the prompts as well, because that's one of the features of the MCP protocol. So,
yeah, so just to add to that, the way I read the spec, and I've been reading the spec quite a lot, is that, and I have kind of the mental model that I now have of the prompts is that it's really from a host side. So if you're using an MCP server that exposes some prompts, then it's all about rendering a prompt with a couple of parameters. So it's almost like giving a suggestion for how you can use the server rather than actually doing a lot of work. So on our side, that could mean that we expose all of our prompting templates in a way through MCP so that you can do something similar. But what that should look like exactly and how that makes the most sense, I haven't fully wrapped my head around, because the return format of prompts is also supposed to be like messages. So yeah, I'm not 100% sure yet how we integrate those into kind of the generic setups.
Thanks, both of you. Yeah, we'll definitely have additional updates as we're diving into this further. I do see a couple of questions that are in chat. For the interest of time, Sergey and Edward, if you don't mind going through a couple of those in chat, I'm going to move on to our next topic so we have some time at the end for Q&A as well. But thanks everyone for diving into this and all of your questions. With that, I'm going to go ahead and move into our GA of Agent Framework. I'd love to turn it over to Dimitro, Chris, and Sean to go through some of our updates there. Dimitro, over to you.
Yeah, sure. Today I want to present our work in progress for Visual Studio Code extension that we are trying to do for the process framework and also agent framework. So let me share my screen real quick. And please let me know if you can see it.
We can see it.
Okay, sounds good. Thank you. So on the screen, you can see the first version of process declarative format. So basically, Estefania already presented an example of process framework today with the human in the loop. So basically, in the process framework, you can configure all of the steps and the relationship between them using C# or Python. Here, you can do the same thing, but using declarative format and YAML. So in this format, we can see some definition of the nodes or process steps. Each node has an ID, some description, and event types it produces. And also, it contains the orchestration, which is basically the configuration of the relationship between those nodes. So each node is basically some unit of work, and in my example, it's a C# code. So, for example, if we open my solution, we will see some steps here. For example, we have a step to get some product information. In this example, we just return some hard-coded information, but in real world applications, it can be, some call to a vector database or just regular database or any data source. We also have a step to basically take that product information and then ask AI to generate some documentation for that product. We have some prompt here to AI, and we have some call to the chat completion service. And then as a last step, we have a publish documentation step. So basically, we take the documentation that was generated by AI, and then we publish it. And in my case, we just simply output it to console for demonstration purposes. So I have this workflow configured and the relationship between those nodes. And then what I can do here, I can press preview process button, and here I will be able to see the visualization of this workflow. Now I can customize it a little bit, and I can change the layout, for example, top to bottom, or left to right. It depends on I think it depends on your prompt definition and your preference, how you would like to observe it. And also, for example, if you have multiple workflows in your solution, you can if you open like a new process file, you will be able to see like another process rendered here, and you can quickly jump between them. And basically, what I can do, since I have my nodes configured and I have C# code that actually performs some work, what I can do, I can press execute process button, which will basically take all of this information with the nodes, their relationship, and basically execute them. And here we can see some output that it's gathering product information. It's generating some documentation for the provided product info, and then we have some AI generated content here. Now, basically what we can do, by the way, this is like, even though this is console application, as you can see here, my main function is empty. So basically the only thing that matters here is just like the definition of the node. So it can be, it doesn't have to be like a console application. It can also be like a class library. The only thing that matters is actually the definition of each step. Now what I can do here, I can add additional step to this workflow. For example, I have report status step, which is some additional step with the workflow basically. And as soon as I save the file, some reason, yeah. As soon as I save the file, I will be able to see that we have this node rendered, but it's not connected to any other nodes. So what I can do, I can directly modify a YAML file and add a specific relationship. But also, it's possible to add a relationship through the VS Code command. So for example, here we have add process H. So now I can select like the source node that I would like to choose. For example, generate documentation step, and now I need to select like the target node. So here I want to select like the new node that I just added. And now I want to select an event that should be triggered to my last node to be executed. So for example, as soon as my documentation is generated, I want to execute report status step. So when I do this, my YAML file will be automatically updated and my node will be attached. And now as soon as I execute this process again, I should be able to see like this step is included. So I believe this is it for my demo. This is work in progress. For now, this preview of the process file, it's read only, and you can modify it basically through the VS Code commands or modifying YAML directly. We are trying to find a good balance between having a good user experience and also user experience that is recommended inside Visual Studio Code extension. But as we go, we will try to improve this experience as much as possible. And for now, this is working only with the programmatic approach when we have a node and we have a definition in sharp code, but it will be also possible in the future to reference your agent definition file, which will basically contain some agent and its responsibilities and so on. So basically, there will be like multiple ways how you can configure your workflow node and basically like what it can do. Yeah, that's my demo today. Thank you.
Thanks so much, Dimitri. Really appreciate it. And then Chris, over to you as well. I'm just sharing back screen.
Yeah, thanks. Well, as many of you might have seen, it is presentation on Friday that we are happy to announce that we've GA'd the agent framework, as Sean has blogged here, and the features that have GA'd is the agent abstractions and some of the single agent agent implementations like chat completion agent. The group chat, for instance, is still marked experimental. So because as part of our AutoGen collaboration, which I think many of you heard us announce, and as we've blogged over the past couple months, we're working on evolving our multi-agent orchestration story in collaboration with AutoGen, and it'll be a lot more powerful and able to scale out for distributed scenarios, for instance, and production scale. I think as part of Wesley recently presented on some update to the agent calling pattern using agent thread, which kind of generalizes our invocation pattern. So I think that was in, last week or the week before. And so that's included as part of the GA. And and then also, as you saw with Satya's announcement, because we've reached this milestone, we're working with the Foundry team to use SK to power agents that are listed in the agent catalog on the Foundry. So taking a lot of steps forward with the agent framework. Sean, did you want to add anything?
I think the main thing that I'd like to add is this is GA for agents, and I think for us that means we feel like the API is in a good place to start building on top of. But this isn't the end. We're continuing to do work to converge with AutoGen, as well as adding more capabilities, especially in the multi-agent space. You'll see lots of stuff coming in there over the next few weeks as well.
Yep. Absolutely.
Great, thanks everyone. Are there any questions folks have? I see there's one Anish in chat for Chris around the Asian group chat. Anything to add there, Chris, as well?
I do agree that when you're using the selection strategy for either of the model-based strategies, just like any prompt requires some tuning, which is somewhat model dependent. If you have, you can always, if you have a kind of a well-defined pattern, you can subclass the selection strategy and take a pro-code approach in terms of the selection logic, which will also eliminate the latency and token usage for the model round trip, the selection strategy. And then also an alternate pattern is to integrate using agents with the process framework, as we've seen the process framework today, which gives you a lot of power and flexibility to manage those transitions conditionally. And then as part of the AutoGen collaboration, for those of you who's familiar with AutoGen, you know, the core agent patterns are based on a runtime abstraction, and we're generalizing what we're calling that runtime, the agent runtime, and our multi-agent orchestrations, what we're up leveling right now, is based on that shared runtime, which is an event-based runtime, which is going to provide a new tool set to be able to manage the agent transitions. And I think, so process framework is event-based and the agent runtime is event-based, although the main difference is with the process framework, as you saw, you're kind of dealing with the graph and defining the edges, kind of conditional edges. And with the agent runtime is more of a pub/sub topics of, you know, kind of a topic-based broadcasting approach. But I think that in terms of that'll really kind of remove the limitation around group chat and selection strategy. Although if you do have a specific issue with selection strategy, feel free to post an issue or ping me directly. I'd be happy to look at it.
Thanks, Chris. And then we have one more exciting topic that I'm going to transition to. I see a couple more questions in chat that we'll get to at the end. And Chris, if you don't mind taking a look. But with that, I'm going to transition over to Ricardo. We have a really exciting guest blog and would love to be able to dive in with him.
Ma siamo sicuri?
Yeah, hello everyone. Nice to be here. Thank you, Sophia. I'm Ricardo. I am part of the Microsoft AI Global Black Belt team in EMEA. And we wanted to share with you a couple of, good takeaways we grasp from the field, general expertise on, let's say, advanced/production grade usage of Semantic Kernel together with the overall Microsoft platform in a series of blog posts. Starting this week, we'll begin to roll out a couple of examples that will eventually build our overall presentation. In the interest of time today, I'll start over the existing one. So around Copilot Studio integration, because as you probably know, this is actually a very highly demanded topic. And so let's move to slides. One of the main aspects we always got question from all the field about is how does your overall platform look like when fully leveraged as a whole? And so you probably know that along with Azure AI Foundry, the Azure ecosystem, and Semantic Kernel as a pro-code alternative, we also offer low-code approaches over Microsoft Copilot Studio. And also Copilot Studio is a local environment that any user can use without any specific expertise to build low-code agents that have many third parties and first-party integration automatically that enables any user to automatically build, publish, test, and maintain agents. But of course, there's no wrong or right approach. And generally, our feedback is the best of all breeds makes the win, especially in an integrated platform like just like Microsoft One. So what I wanted to show you very briefly in this series is first, how you can integrate a semantic kernel natively in Microsoft Copilot Studio back and forth. Starting from an example here, yeah, maybe you can move the slides because my PC is not very responding.
Let me see if I can.
Okay, thank you. Okay, thank you. So first scenario, picture this. You may have a complex orchestration system being built in semantic kernel that your developer have been building and publishing on whatever technology you prefer, but you also want to leverage some other business teams have been building as a local platform and want the semantic kernel to leverage those and orchestrate a varied set of different kinds of agents. As you probably know already today, Semantic Kernel allows you to orchestrate different kinds of agents regardless where they are built with or hosted. So you have Crew AI, you have Azure AI Service Agents, you have OpenAI Assistant, and completion ones. So we thought it would be nice also demonstrate how to leverage the same approach by subclassing the basic agent class to talk with Copilot Studio as a first-party agent, and then match the basic API we all use all the day through single agent or multi-agent chat. And so in one of the examples that we published together with the rest of the SK team, you can see how to publish a Copilot Studio agent on Copilot Studio And instead of consuming it natively from its standard interface, you can include it in an agent group chat with traditional APIs, which will be a highly usable approach to make Semantic Kernel the very core of orchestration engine, regardless of the eventual implementation you use for dedicated agents, also improving a lot the usability and discoverability of agents on a high-end platform in an enterprise. But of course, there's a slightly more tricky scenario in which you would like to pitch the other way around of Copilot Studio being extended with Semantic Kernel. And for such, I have a small video that hopefully will play. Let's try. Let me know if you hear the audio.
We do not hear the audio.
Doesn't look like. Allow me a moment to play back that from scratch.
Yeah, Ricardo, I think if you share and then share with audio,
yeah,
that may
absolutely.
work.
I just have my PC lagging a little today. So let's try back. Now you should be hearing.
In this video, we will show how to extend Copilot Studio agents with a pro-code approach, leveraging Azure AI, Foundry, and Semantic Kernel. Microsoft Copilot Studio enables users with varying skill sets, from citizen developers to business analysts, to rapidly deploy intelligent AI agents and automate workflows. Yet still, some real-world scenarios may require highly specific orchestration between agents, advanced integrations with existing systems, or complex processing. In such cases, we can leverage the extended Microsoft platform to seamlessly integrate Copilot Studio with Azure AI, Foundry, and Semantic Kernel by constructing a custom skill. A custom skill consists of an API linked to an Azure Bot Service instance that Copilot Studio can register and talk with over a unified protocol. Once we deploy our Semantic Kernel skill on Azure, we can smoothly add it to an agent in Copilot Studio. We go to Agent Settings and select Skills. Then, we specify the skill manifest URL and hit Save. At this point, the skill will be usable within Copilot Studio. For this demo, let's create a new topic for our agent. We will instruct Copilot Studio to trigger on SQL query requests. And as a subsequent action, we want to invoke our new Semantic Kernel skill from the dropdown. Once your topic is configured, you can click Save and provide a name. Now we're ready to test it in action. By using the test pane, we type our SQL request in natural language. Copilot Studio will correctly identify this is a case for the SQL topic and route to the skill. And finally, here's the response directly from our remote Semantic Kernel agent, which run in natural language to SQL process.
Yeah, so as you just saw, we also had a bit of a spoiler of what's coming next, because one of the key aspects we'd like to clarify is the added value that Copilot Studio can achieve with Semantic Kernel. And so in this diagram here, you see that we have multiple elements involved, mainly on the Azure side in the forms of Azure Bot Service, acting as a relay between the Semantic Kernel application and Copilot Studio over a standard direct line protocol authentication mechanism. But the good stuff is you can really build very advanced and complex solutions, much like the one we're going to pitch hopefully next week about how to design a complex feature like natural language to SQL processing, which is quite varied, deep expertise, but is also highly valuable to businesses because it unlocks a number of easy to access scenarios over corporate data on traditional databases, all in a reusable manner that also multiple agents in Copilot Studio can share and reuse, all built with Semantic Kernel Process Framework, but not spoil it too much for now. Thank you for your time.
Thanks, Ricardo. Yeah, looking forward to part 2 and diving into that next office hours. Are there any questions that folks have for Ricardo?
I do have one. Sophia, this is the best session ever. Lots of announcements, new things. It's just saying very loud. If this is like that, I think we need like half an hour more, if not more time for the open office hours. It's been fantastic. Thank you.
Yeah, thanks so much, Jose. There's definitely a lot of updates this week, so appreciate everyone joining in and asking all your questions in chat. we are at time, and so I'm happy to stay on for a couple of minutes if there are any pressing questions that folks have, but please make sure in the interim to use GitHub discussions. We go through and triage daily, but there are a lot of updates and exciting things that are coming from the Semantic Kernel team, and so this session has really been focused on some of those updates, but we'll definitely in coming sessions have a lot of time for your Q&A, but wanted to make sure we could go through and do demos of all the goodness coming. So just looking through chat to see if there are any questions. Does anyone want to come off of mute if there are any questions folks have?
I do, so I take the chance. I've been digging in the GA of agents, so I already proposed a couple of issues, right? The open source ways. So I proposed one which already was assessed by Chris. Thank you, Chris. That's very kind from you. Regarding the thread on the when we generate have different agents, the ability to add the agents as plugins. So that's super cool. Thank you for having that. I propose as well a kind of an overload, so we can code it the same way as in Python, which is simply add the agents and not having to convert them to functions, right? And doing that, I realized that the thread is not given, right? So it's one of the issues. I think that's important. I just want to mention that it's already an issue created. So, and Chris knows, I think Mark Wallace is also acknowledged on that part. And the other thing is in this regards, it's I'm super hooked on MCP. So it's super exciting. And yep, also for Dimitro, I have a question is when we'll be able to debug process in Visual Studio Code, because visualizing is super cool, but I really want to start trying it out and having the ability, probably not yet to design, but to debug. That would be fantastic.
Yeah, I think.
Yeah, thanks for the question, Jose. Dimitra, over to you. I know we're in the process of getting a Visual Studio Code update, but over to you, Dimitra.
Yeah, sure. So in the first version of this extension, most probably, we will focus on the visualization and how to work with the declarative format and so on. But I think that the debug experience can also, be implemented at some point. We also need to investigate how the debug experience will look like. I mean, when you have a node that is programmatic defined in C# or Python, that's understandable how you would debug that. But for example, when you have a node that relies on some agent which has some declarative definition as well, we will have to investigate how to properly debug that. But I'm pretty sure that we will come up with something at some point.
Great, thanks, Dimitra.
Thanks a
really
lot.
appreciate that. Well, with that, we're going to go ahead and close our office hours today. Thank you so much, everyone, for joining in. We look forward to seeing you on GitHub discussions with questions you have, and look forward to seeing you in next week's office hours. Thanks, everyone.